Okay, here we are again. Now we're looking at number 6 on your homework packet, and we have the circus performer twirling a bucket filled with water. Sounds kind of clownish, like me maybe over Jimmy's head earlier in the month. Well, we have two different situations we have to consider. The top and the bottom of the circle that this bucket is getting twirled in. Now we have gravity, which is shown in the upper right-hand corner as 9.8. Now we often show that as negative 9.8 because it's directed downward. So since it's directed downward, and look at my black arrow, which is at the bottom of the circle, it's also directed downward. So when they're in the same direction, we would add those two things. Whereas at the top of the circle, the centripetal force as well as, well, gravity are working in opposite directions. And so then we subtract one from the other. So why don't we start with, well, the subtraction. And so we start with our top of the circle, and we say, well, mv squared over r minus mass times gravity. Now that's just the two formulas. Rather than just saying Fc and Fw, I end up putting in Fc, the equation for that, and the equation for Fw. And now we can put some values into this, in which we have a 20 kilogram bucket. We have a velocity of 11.5. We square that just according to the equation, if nothing else. And this all goes over 0.500 meters for a radius, minus 20 kilograms times 9.8. And then we press a few buttons on our calculator, and what you will find is you get 5,090 with sig figs. On the other hand, at the bottom of the circle, we simply add these values. And so at the bottom, you end up with your 20 kilograms times your velocity. And then we add our mass times gravity. And you get the grand total of 5490. Most excellent.